Hi, today we'll be doing chapter 2.4 on gradients of straight line graphs. Today we will learn what gradients are, gradients of straight lines, what are the steps to calculate the gradient, and for us to calculate it easily we use a formula, and of course the types of gradients that we will see for straight line graphs. Let's do a quick recap. This is the coordinate plane, Cartesian plane, and usually for this plane we would plot a couple of points and then we would join them together using a straight line. So this is the straight line graph. So what's next? We will probably need to calculate the gradient of the graph. So what are gradients exactly? Gradients tell us how steep a line is. It's also usually expressed as just a number or a fraction, or it can be a decimal. Examples of gradients that we come across are, for example, a positive number, gradient equals to 1. Or it could be a negative number, gradient equals to negative 1. It could also be a decimal or a fraction, 2.5 or 2.5. So how do we go about calculating gradient of a line like this? First, we pick two easy points. So those are points that are easy for us to see. So I'm going to pick this point which I call B 2, 3, and I'll pick another point A 6, 7. Okay, then after that I ask myself, for between these 2 points A and B, what is the change in the y coordinate? Can you tell what's the change in the y coordinate? Yes, it is this distance. Next, I will ask what is the change in the x coordinate. So between these 2 points, I only want to know what is the x distance. And it is this blue arrow. Once I have these two, I can now calculate my gradient, which is the change in y divided by the change in x. So in the previous example, if I put in the numbers, it will look something like 7 minus 3, which is that distance between the red arrows, and after that the blue arrows, which is 6 minus 2, and the gradient is 4 divided by 4, which is equals to 1. So the gradient of this line is 1. What do you realize about 7 and 6? Yes, they are both coordinates of A, the x and the y coordinate of A. 7 is the y coordinate of A, and 6 is the x coordinate of A. How about 3 and 2? 3 is the y coordinate of B, and 2 is the x coordinate of B. Do you realize they're over each other? So now, what if I replace the numbers with general letters? So for A, XA, YA means the x coordinate of A and the y coordinate of A. And for B, XB, YB, it's simply just the x coordinate of B and the y coordinate of B. So I still have to find the distance in the blue and the red arrows. Okay, so how do I calculate the gradient? So the gradient in that case would be a fraction, the red arrow, which is YA minus YB, over the blue arrow distance, XA minus XB. Once again, you realize that YA is over XA and YB is over XB. And that is how we calculate the gradient using the formula. There are many types of gradient that we come across. Actually, there are only 4 types. So just remember that it looks like an umbrella. We have the positive gradient, which looks like this, goes up from left to right, and we have the negative gradient, which goes down from left to right. And we also have 0. It's a flat line. There's no change in y. It's flat all the way. And of course, we have one that goes all the way up. That is undefined. okay, because there's no change in x at all, but there's a change in y. So it's called undefined. So when they ask you what is the gradient of this, you just say undefined. And that is all we have for chapter 2.4.